In this question, we're going to deal with this same process in a slightly different way. So last time we thought about dissolving carbon dioxide gas in a beverage with, Kp 0.034 for this process. And what we did in the first problem is we gave you the equilibrium value of the carbon dioxide gas, and from that we solved for the equilibrium concentration of dissolved carbon dioxide. This question is going to be a little bit different, and it's going to be a little more difficult. In this case, what we're going to do is we're going to take the beverage and we're going to seal it initially at 4 atmospheres. So in this case, this is not the equilibrium pressure. It's the initial pressure when we first seal the bottle. And then we're going to ask ourselves, what's the equilibrium concentration of dissolved CO2 that's expected in our beverage that was initially sealed at our carbon dioxide pressure of 4 atmospheres? So this is going to require the use of an ice chart. So I'm going to write out my expression or my chemical equation. So I've got carbon dioxide gas going to dissolved carbon dioxide. And I can, of course, write that Kp for this process is going to be the concentration of CO2 at equilibrium divided by the pressure of CO2 at equilibrium. We don't know what the equilibrium concentrations are, but we do know the initial conditions. We're going to try to figure out the change that occurs, and then we're going to get to our equilibrium value. So in this row, I'm going to place my initial conditions. Well, they give me an initial condition of 4 atmosphere of CO2 gas. We'll assume that there's no carbon dioxide in the headspace when it's initially sealed. No carbon dioxide dissolved when the fluid is initially sealed, the beverage initially sealed. There's going to be some change that occurs to give us our equilibrium concentration. What's the change that's going to occur? Well, we don't know. So we're going to call the change X. So the amount of carbon dioxide gas, well, some of it's going to go into the beverage. So we're going to lose a certain amount of this. So we're going to lose, we'll call it X amount. And by stoichiometry, we know that if we lose X amount of carbon dioxide gas, we're going to gain X amount of dissolved carbon dioxide in the beverage, because the stoichiometry is 1 carbon dioxide gas molecule for every molecule of dissolved carbon dioxide. So our equilibrium values are going to be 4 minus X for the pressure, and 0 plus X, which is just X, for the amount of dissolved carbon dioxide. And now what we'll do is we'll plug these equilibrium values into this equation and solve for X. So here's how we can do this. I'm going to put my value of X in for my equilibrium equilibrium concentration of carbon dioxide. So that goes X on the numerator. We're going to divide that by the equilibrium pressure of carbon dioxide, which is 4 minus X. And this should be equal to Kp, which is 0.034. And now it's algebra. I just have to solve for X. So I'm going to get rid of 4 minus X on the denominator. So I'm going to multiply both sides of this equation by the quantity 4 minus X. This cancels this. And now I have an equation where X is equal to 0.034 times the quantity 4 minus X. I will distribute 0.034 into the parentheses. So let's see. I've got 0.034 times 4. That's 0.136. So let's see. That gives me X equals 0.136. That was this times this, minus 0.034 minus times a negative X, which is 0.034X. We're almost home. Now I'm going to add 0.034X to both sides, plus 0.034x. This cancels. X, that's just 1x, right? So 1x plus 0.034x, that's 1.034x. That's on this side of the equation. And on this side of the equation, we just have 0.136. We divide both sides of our equation by 1.034. That cancels. And x is going to be equal to 0.136 divided by 1.034. So x is 0.13. Now, math class, when you solve for x, you're done. In chemistry class, you got to go back and make sure that you've answered the question. So let's make sure we've done this. What the question asked is for the equilibrium concentration of dissolved carbon dioxide. Well, let's look through here. Here it is. Here's my equilibrium concentration, right here, the E of dissolved carbon dioxide. There it is. Hey, that just happens to be X in this case. And so we know that the answer to this, X is 0.13 molar. If it was asking for the equilibrium pressure of carbon dioxide, we would have another calculation to do. We'd actually have to take 4 and subtract 0.13. Let's just go ahead and do that. So 4 minus 0.13, 3.87. And in this case, we have solved for the equilibrium pressure of the carbon dioxide at equilibrium, which would be 3.87 atmospheres.